All right, guys, this is a review for 8.5. We're going to be using terms like multiplicity and factoring and finding the solutions to polynomials. So this is something that we've covered, but it's been a while, so I just want to give you a review in case you don't remember how to do it or what some of those terms mean or how we apply them. So if you know what I'm talking about, you don't have to watch this video. There won't be any homework on it. This is just for you to refresh your memory. Okay, so the first thing we're going to do is factor 3x to the fifth plus 18x to the fourth plus 27x cubed. We're going to find the solutions for it, and we're going to give them a multiplicity of them if there are any. So the first thing when we're factoring, we want to take the GCF. Okay, so if I look at this, I can see that they all have x's, and they all can be divided by 3. So my GCF out here is going to be 3x, and I can take a total of 3 x's. So 3x to the fifth divided by 3x cubed gives me x squared. 18 divided by 3 is positive 6. X to the fourth, x cubed leaves me 1 here. And then 27 divided by 3 is positive 9. X cubed over x cubed, and they cancel, equals 1. Both of this is equal to 0. Okay, now one of the big mistakes that you guys make is that you don't continue to factor. So we have to look at this and see if we can factor it at all. Remember, this is A, B, and C. When you're factoring, you create your table over here. A times C, sum to B. So A is 1 times C is 9. We're looking for the factors of 9 that sum to 6. So positive 3 give me 6. That's what I'm looking for. You can factor by grouping or by bottoms up. I'm just going to put them into the factors because it's easier. So we have x plus 3 over 1, x plus 3 over 1 is equal to 0. Simplify my fractions here. I'm using bottoms up. You can also use grouping. It doesn't matter which way you get here. Okay, so I have 3 factors. We're not done. The first thing we did was factor completely. So this is factored. The next thing we need to do is solve. So in order to solve, we're going to say each of our factors equal to 0. 3x cubed is equal to 0. X plus 3 is equal to 0. X plus 3 is equal to 0. So if I want to solve this, I would divide each side by 3. Okay, so divide by 3, divide by 3. And that is going to give you 0 over 3 is 0. The cube root of 0 is 0. So x is equal to 0 here. Here I would subtract 3 on each side. X is equal to negative 3. Same thing here, minus 3. X is equal to negative 3. We've found the solutions. Remember, when we give our solutions, you have to give them in roster notation. Okay, remember roster notation was just the list of them. So from least to greatest, we have negative 3, and 0. Now, because we have negative 3 twice, we can state that as multiplicity of 2. So when we would write it in our roster notation, we would only have 2 zeros there, where negative 3 has a multiplicity of 2. Okay, so that is what we want. We've stated the multiplicity, we've given the solutions in roster notation, and we factored it completely. Okay, so what I'm looking for is this over here and this down here. We'll do it one more time. Okay, I have another example here. We cannot solve this the way it is. We have to add this 36 to each side. Okay, we cannot combine 36 with any of these. So it hangs out in the back. X to the fourth minus 13x squared plus 36 is equal to 0. I'm going to do this one by grouping because we have the higher order exponents. So I still have A times C, so we're looking for the factors of 36 that sum to negative 13. Since this is negative, I know both of my factors are also going to be negative. This is negative, this is positive. Both my factors have to be negative. So if you look at this, not 6 times 6, it's going to be 9 and 4. Negative 9 minus 4 is negative 13. I'm going to split this up here. And it doesn't matter which way you do this, guys. If you have the higher order powers, I'm going to say do it by grouping, because the bottoms up isn't always going to work that way unless you know to factor that out. So we have x to the 4th minus 9x squared minus 4x squared plus 36 is equal to 0. Split up your two sections. Factor out the GCF here. I can take out an x squared, which leaves me with x squared minus 9. Here I'm going to take out a negative so that my signs will line up. I can take out a negative 4, which is going to leave me with positive x squared minus 9. Check your factors, they add up. So we have x squared minus 9 times x squared minus 4 is equal to 0. And we're not done. These can be factored even further. These are the difference of squares here. So in case you don't remember, if we want to do this one, we would have 1 times negative 9, where b is 0, and the second one would be negative 4 and 0. So the factors of negative 9, so a times c, are going to be negative 3 times positive 3, and the factors of negative 4 are going to be negative 2 and 2. Both of those will sum to 0. So our factors over here are x minus 3, x plus 3, x minus 2, x plus 2, all equal to 0. And now we can solve each of them by setting each one equal to 0. I'll do that over here. So we have x minus 3 is equal to 0, add 3 to each side, x is equal to positive 3. X plus 3 is equal to 0, minus 3 on each side, x is equal to negative 3. X minus 2 equals 0, add 2 to each side, x equal to 2. X plus 2 equals 0, minus 2 on each side, x is equal to negative 2. So we have our solutions right here. We want to write them in roster notation. 3, negative 3, 2, negative 2. Okay, there is no multiplicity. They're all listed once. You can always put them in order, which we want to do. So negative 3, negative 2, 2, and 3 there. Okay, so these are all of our solutions here for that equation. So that's what we're doing. I'm not going to give you any practice problems. Just make sure you understand what we're talking about when we say factor, find the solutions, and give the multiplicity. If you have any questions, let me know. Shoot me a message or a remind. Otherwise, I'll see you in class.